Good day everyone! So for today's video, we are here to explain the data encryption standard process of the convert to bits, initial permutation, expand write,
XOR Subkey, substitute, and permute.
XOR left, rotation halves left 1, and extract bits.
convert to bits. In the convert to bits, it simply convert the plaintext input, the key input, and ciphertext output into binary. So for example, 1. So what is the binary of 1? It is 0001. How about 2? The binary of 2 is 0010 and so on. So that would be the result in the convert to bits. Initial permutation. In the initial permutation, it is based on the IP matrix or initial permutation matrix, where all rows and column numbers inside the IP matrix can be seen at the top, above in the arrow, where all you can see the indicated numbers 1 to 64. And every number has a specific value that can be seen in the result of the convert to bits. For example, 54, which is the first number in the matrix, and its initial permutation is 0, that can be seen in the result of the convert to bits. Another is 50, the initial permutation is 1, and so on, until 64 bits are generated. Expand write. In the expand write, take the right half of initial permutation. Then, you replace these bits instead of 33 to 64, replace into 1 to 32. Then, look for its EBIT selection table matrix. Now, all the numbers in the matrix have its assigned values or binary there in the yellow line. After you get all their assigned values or binary, you can now arrange it in one line, and done. You already have your expand write result.
XOR Subkey. Get the result of the expand write and the XOR Subkey under the key schedule. Then, get their XOR value. Remember, if they are the same, it's 0. But if not, it's 1. Easy as that. Substitute. In this process, they group into 6 bits. First thing you need to observe is the left side and right side value. That sides serve as the row in the matrix and the middle values are served as the column. You need to know the decimal of the 4 bits value. Then, do the process of counting into S1 to S8 matrix. For example, the answer in the set matrix is 7. So convert it into its binary and that will be the result. Same process to the following until 32 bits generated. Permute. It is based on P matrix also into the indicated numbers 1 to 32 as your basis. After, find and look the value of the given numbers into the matrix into the result of substitute.
In XOR left, to get the answer of XOR left, you need to get the right initial permutation and that serve as your left of your XOR left. Then for you to get the right of XOR left, get the half left result of initial permutation and the result of permute. Then look for the XOR value or binary. So what would be the result? Will be the right half of your XOR left. In the rotate halves left 1, it is based on the initial permutation of key schedule. One left shift rotation takes place, where the first value in the initial permutation of key schedule will be the last value or binary in the rotate halves left 1. In the extract bits, it is based on the PC2 matrix, and all numbers in the said matrix has assigned values or binary that you can see into the result of rotate halves left 1. So what would be the output value or binary will be the result of the extract bits.